Recursive, this is your guys' least favorite because recursive is step by step. And some of you want that equation and you can just drop the 5 in there and it spits out the answer at the other end. So recursive, 2 things you need to know. Where do I start? And what's the rule? Those are the 2 things you need to know for recursive. So when you look at this very first problem, I'm telling you where to start, and I'm giving you the rule. So my a sub 1 is 4. N plus 1. What this is telling you is add 1 to the what they call an index variable. So you're going to bump it out 1. So what's the next?
2.
We look for step 2, right? Well, what does this mean? If I'm looking for step 2, right?
4 squared.
That would be like 1 plus 1 right here. So that means this n is a 1. So what it tells you is, look at your previous answer and do what to it? Subtract 8. So 4 minus 8 gives me negative 4. Step 3. What do? Well, I go back and look at my answer for step 2 and subtract 8. So I get negative 4 minus 8, which is negative 12. And then we're supposed to find the first 4 terms. So a sub 4 is
Negative 12.
negative 12 minus 8, which is negative 20. Now, I don't find a sub 5. Yes, they gave me a sub 1, right? The instructions don't say, hey, I'm giving you 1, find an additional 4. It says find the first 4. What are the first 4? A sub 1, A sub 2, A sub 3, A sub 4. Got it?
Got it.
There are the first 4 terms. With somebody sitting near you, you're going to work on the second one, part B over there. First 4.
Put 1 in here. Look at the answer.
Negative 1, 2, 5, 26.
Can't believe
You just plug in 1, 2, then 3, then 4. So I shouldn't say it that way, but you're finding 1, 2, 3, 4. But recursive, because it goes step by step, if I want to know the 100th term for recursive, what do you have to know? Probably 99, right?
Yeah.
Now, the point would be, some of you, and we'll ask you to do this eventually, if you look at a recursive, you can switch into what we call the explicit, which would allow you to go directly to that answer later on. So there are ways to speed up the recursive stuff, but oh, I don't know this one. Okay, factorial. Right here. Math button right there. Slide over to the probability menu. It's number 4. So 6, math, probability, select number 4, it puts the exclamation point behind the 6, and I get, well, what is it doing?
It looks like, or 6 by 5.
Yes, it took 6 times 5 times 4 times 3 times 2 times 1. You multiply all those together, you get your 620. So, what is 0 factorial? That's developed by doing some other rules in mathematics that you can do. 0 factorial, if you do divisions and stuff, you can see it easier, is 1. That is kind of one of the most missed things later on. Like we have some multiple choice questions. It's very easy for people to forget that. It's defined as 1. It's not a 0. It's a 1. 1 factorial then is 1. 2 is 2 times 1 or 2. 3 factorial is 3 times 2 times 1, which is 6. At some point, you would want to stop writing them all down and use your calculator, but 4 factorial could be 4 times 3 factorial, right?
Yeah.
Or, you know, you could go 4 times 3 times 2 times 1 if you want. So just multiply your last answer by 4 and I get 24. 5 factorial is just to take your last answer here and multiply by 5. You get 120. What's 7 factorial? 5,040. Good. That by the time you get up there, you're probably wanting to do the factorial on the calculator. So again, please, with somebody sitting near you, write down the first 4 terms. And think about, does n squared or n factorial grow faster? Which one grows faster? Okay, think about that as you go. I'll pause it, and then we'll put the answer. So if you look at the work, a sub 1, a sub 2, I've shown you the work, 3 factorial, 3 squared, all that stuff. How can I tell which one grows faster, the top and the bottom? What's gonna give you, or what's the indicator you'd use? Yeah.
Because when you get to a certain number, you're multiplying by 4, and then just.
Well, which one's growing faster though? N squared or n factorial?
Fast.
Yep, faster. Which one?
The square jump.
In the beginning, I have 1 over 1. They're identical, right? A sub 2. 2 squared is 4. 2 factorial is 2. So all of a sudden, the n squared term is out in front, right?
Yeah.
Because the number on top is clearly larger. Then a sub 3, I still have 9 over 6. It's still larger. A sub 4, 16 over 24. Now there's a change, right? Which one is growing faster? All of a sudden, the bottom is going to take off, and the indicator really is that these answers, as you move out to the right, they're starting to get smaller again. So it went from 1 to a 2, it jumped up. Now it's at 1.5, and now it's at 2/3 or 0.6. So now our answers are coming down, which means the bottom of the fraction is getting larger. Okay, so because you guys have the graphing calculators and larger numbers, when my calculator was called a scientific calculator, I believe it could do 10 digits. It would show 10. Calculators that first came out could only show 8. So you could only go up to the 10 million digit. And I can't remember how many you guys can get across, 12 or something. So your life's a little bit easier because you have the calculator. So what we used to have to do, and I don't remember, the scientific calculators, once you got to like 10 factorial, I think actually aired out on you. It was too big a number for it to display. Okay, so what we would often do is go 10 times 9 times 8 times 7 times 6 times 5, times 4 times 3 times 2 times 1. I'm being a little bit sarcastic here, but 2 times 1, I like this, and you'll see why in just a second. Because what are we going to do? We're going to go chunga 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 chunga. So what's left? 90 over 2, which is 40. Okay. Make sense how you're doing that?
Yeah.
What you're trying to do is line up so that the factorials match and you can just get rid of them. Really, a person in math would do this: 10 times 9 times 8 factorial. We wouldn't write both of these out. We'd stop there and cross them off.
Oh.
Because if you understand the pattern, I mean, from what you're saying is, from here on, both the 8 factorials behave the same, so I'm crossing them off. N factorial on top is starting at n. The rule of factorial is that you're moving down one integer from there. We never know what n is, but it's n minus 1. Then the next one would be n minus 2. What's the next one?
N minus 3.
N minus 3. Next one would be n minus 4. Do you see the pattern? Do I need to continue to write the pattern? No. So we're going to just go dot, dot, dot. The pattern continues. How far do you go with factorials? Where do you stop?
Never.
When do you stop?
Never.
No. When do you stop? Do you, when you get to 0, do you go negative times negative 1 times negative 2 times negative 3? Where do you stop when you write out factorials? What? 1. You get down to some point where, even if you're at 100, eventually you get down to that part where it goes 3 times 2 times 1, right? Make sense?
Yep.
You don't keep going with more integers. Once you reach 1, you're done. Stop writing out and now multiply it, right? So, n minus 1, n minus 2, you just keep subtracting another number, dot, 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 the pattern continues until you get to the point where it goes 3 times 2 times 1. I just don't know where you're starting, but I know you'll do that. On the bottom, we're starting with our first number is n plus 1. What are you going to do?
N minus 1.
Take 1 away. What's n plus 1 minus 1? N. Take another one away. Where is it? N minus 1. Take another one away. Where is it? N minus 2. Got the pattern?
Sure.
The pattern will continue until what?
3, 2.
Until you go 3 times 2 times 1.
I don't get it.
What's the same? Everything from n out there, right? Now, when you cross things off, you're really leaving a 1 behind. So this ends up being 1 over n plus 1. To help you understand, you might have gone, let's say, 20 factorial over, if I say the top is 20, what's the bottom?
20 plus 1 factorial.
21 factorial. So what would be left over? Your top number plus 1. So if you put 20 on top, you'd be left with 1 over 21 on the bottom. It's always, there's one extra term on the bottom. Okay, let's do another. Factorial, you stop when you get to the 1. 3 times 2 times 1. So that's what I'm indicating is, I could start you at 1,000,000, 999,999, 900, you know what I mean? So you would be subtracting 1, but eventually you will get down to 3 times 2 times 1. So all factorials match up at some point. Let's try this one. Think about what they're asking you to do. Pick a number. Put a number in your head.
4.
In your head. Take that number minus 2 and take that number minus 4. So for instance, if I do 100, if I put the number 100 in my head, the top number would be 98 factorial and the bottom number would be 96 factorial. So as I write this out, 98, 97, 96, 94, 95, all the way down 3, 2, 1, and I do 96, it's going to start at 96, 95. Where do you have more numbers? The top has more stuff in it, right? Okay, so n minus 2 is where you start. Take 1 away, where are you at? Take 1 away, where are you at? N minus 3. Take 1 away, where are you going to be?
Minus 4.
Do you see the pattern? Dot, dot, dot. 3, 2, 1. Start at n minus 4. Take 1 away, where are you going to be? N minus 5. Do you see the pattern? Good. 3, 2, 1. So where do they start behaving the same?
Minus 4.
At n minus 4s. So cross this off and everything that way. Cross this off, everything that way. And you're left with n minus 2, n minus 3, all over 1. So really the answer is just n squared minus 5n plus 6.
Oh my God.
I just multiplied, FOIL the top. Just FOIL the top, FOIL it. I'm going to pause. You guys are going to work on part D. Try to figure out where they line up, where they behave the same, and then I'll put the answer up there. That should be your answer, 1 over n squared plus 7n plus 12.
You're such an idiot.
Now, if you didn't get that, here's what it would look like. Here's what it would look like. On top, you might have written out n plus 2, n plus 1, n minus 1. You got the idea. It goes 3 times 2 times 1 at some point. On the bottom, though, you have n plus 4, n plus 3, taking 1 away every time, n plus 2. And at this point, you might have said, hey, wait a minute. That's the same as that right there. So you go dot, 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 3, 2, 1. So they start to match up at n plus 2s, and everything to the right is gone. So you have 1 on top, n plus 4, n plus 3 on the bottom, and we multiply that out, you get that quadratic.